world, tutorial assistant, collections manager for many museums, including the Autry National Center in California, the Maxwell Museum, MIAC, as many of you know, and most recently at the Wheelwright. And I have decided to take a break from the museum world, and I'm currently coordinating efforts to help get folks vaccinated in the state of New Mexico through the Department of Health. So if any of you are trying to get vaccinated and haven't been able to yet, feel free to shoot me an email. My career as far as bioarchaeology goes started almost 20 years ago during my undergrad at UC Riverside, and it's been fun and challenging, which is something I like about it. For those of us who are bioarchaeologists or osteologists or forensic anthropologists, we tend to see the human body sometimes as a puzzle, and identifying fragments is part of that big puzzle that we look at. What we don't always verbalize when we're looking at this stuff is some of the questions I'm going to go over with you guys. For us, we can pick up a bone and in a second, sometimes half a second, we know exactly what it is in the big scheme of things. But we're going to break it down into tiny little pieces so that you guys can start to understand where to start when it comes to just identifying human bones. As I said, I've got almost 20 years of experience with the human skeleton, including my master's degree in forensic anthropology and my PhD focusing in bioarchaeology. And the best thing I can tell you is in order to identify human material really well is you got to get to know it. These are 3 books that I highly recommend. If you get the hardbound version of the middle one, it gets pretty pricey, especially if you're going for a newer edition. You don't really need to get the newest edition. And some of the digital copies of these books range from like 10 to 30 bucks. And they're really to have like on a tablet or a phone so that you can easily compare stuff in the field. Okay. And the reason I emphasize the whole you really got to get to know the human body is human osteologists on average are better at identifying faunal remains than faunal specialists because we spend our entire career getting to know one species. So we can say whether or not it's human really quickly. And then after that, it's default into animal. And I've actually had this happen numerous times to me in the field where I've gotten into arguments with faunal experts and they're like, no, it's human. And I'm like, no, it's not. And I point to them why it's not human. And then they realize, oh crud, I got to figure out what animal this is. And that's where faunal experts tend to have a bigger problem is because they've got a lot of species they're expected to identify. So before we ask if it's even human, is it bone? A lot of individuals, they'll find stuff on the ground and sometimes it'll have the morphology of bone, but it's not. It could be wood, it could be plastic, it could be rock, it could be shell. So here are some examples where some people might get a little confused. Here we've got a piece of fossilized coral where it's got somewhat of a spongy appearance like certain bone does. I put this in as a joke. By plastic, I kind of mean like a tiny little shard of plastic, most likely like a high density plastic. Sometimes when they fragment, and especially if they're like a white or creamy color, sometimes they'll look like some cortical bone fragments. And that's where it's really important to kind of feel it with your finger, if it feels really smooth, or if the rough texture is very uniform, much like something that's been produced by man, that's something you would look at. And then there's the difficulty of fossilized wood or petrified wood and shell. And what you want to look for there is the tight compactness and the uniformness of it. Human bone tends to not be super uniform like shell as it lays down in layers, and similar with trees. So you just kind of look for those uniform lines and you'll tell. And there's the age-old, well, you can always lick it. A lot of archaeologists have kind of started to move away from this, especially if it's human remains, out of respect to the humans. But it is true, certain things will stick to your tongue, and bone is one of those. I've actually found that over the years, certain species will actually stick more to your tongue than others. Whale and bird, because of the porousness of the bone, it has more of a kind of a Velcro feeling to your tongue than human or dog or other mammals, such as like that. But once again, depending on where the bone has been, I don't recommend licking it. Don't be a geologist or an archaeologist, just, use your other senses. Next, we want to ask, is it whole or is it fragmented? And that's a simple question, but it's one that you need to answer because you need to know if you're looking at the entire thing. And fragmented, as you can see in the picture on the left, is typically really easy to identify. You see these breaks and you see that it's not complete. However, the picture on the right actually shows some pathology. Those are some finger bones right there. And while they're whole, you know that they're not necessarily complete because they're missing little bits and pieces. So in your head, you have to be like, okay, well, what did this look like before this pathology changed the bone? And then you can kind of start to think, okay, well, what does this look like on a human? So that's why we start thinking, well, is it whole, fragmented, in that nature? Once again, this is all before, is it cranial or postcranial? And the reason we ask this before we ask if it's human is because we need to know where this bone belongs in either species. Okay, the cranial bones are typically relatively thin and flat. Some of them have slight curvature to them, but once you break them down into smaller bones, they're going to be flat. Typically, your frontal bone, which is your forehead, and your occipital bone will have the most, which is the back of your head, will have some of the most curvature. Okay. You're also going to see a lot of sutures, which are squiggly lines where the bones come together. Some species have more squiggly lines than others. So that also helps. You want to look at the structure of those lines where the bones come together. And then you've also got sinuses. So right here, you can see, for those of you who suffer from seasonal allergies and head colds, that's the frontal sinus, which is right here on this skull. So basically, when you get a sinus headache, that's filling up with all sorts of gunk. But these are the things we look for as osteologists to determine, well, that's a cranial fragment, because we tend to only see these type of sinuses in the head. And then we also look for different sockets, the eye socket, tooth sockets, things of that nature that kind of tell us what it is. And the reason we ask this once again before we ask if it's even human is because we want to be able to identify where it then goes in the human or in the animal. We need to know what part of the body we're looking at. So then the obvious next question is, if it's not cranial, it's probably postcranial, meaning everything below. And this includes a lot of long bones, a lot of skinny bones that can be somewhat flat. There are exceptions to that general kind of rule, okay? Oh, sorry, I have a toddler running loose, sorry. So here you see some of the long bones, okay? And the exceptions tend to be in the feet, the hands, the vertebrae, and the pelvis. And in the hands and feet, they're not so much flat as more rounded. And in the pelvis, as you can see here, it's not exactly flat. A lot of osteologists I know, whenever they see a curved piece, they think pelvis right away. If not, they think cranial, because it's not truly flat. You've got all sorts of curvatures going in all sorts of different directions. Okay. And we'll see more pictures of vertebrae later in this slide. And you'll see that it's very much like the pelvis in that you've got projections of things going off in different directions and you've got a lot of curvature. The next question we ask, and once again, this is even before we get to the if it's human or not. Did this bone belong to an adult or a juvenile? And we can quickly identify that. It's probably the easiest question to answer, no matter what species it is, because you will see stuff that is unfused and underdeveloped. Here you can see some phalanges where in an adult of this species, this line would not be visible. And in very young individuals, these are actually two separate bones. Okay. And here you see a vertebrae, and a lot of people who don't study juvenile osteology sometimes don't realize this, but all of your vertebrae start off as multiple bones that then fuse together. So this would be the body of the vertebrae, and then these are the neural arches, and then the spinal column goes in here. So, and you can see what's interesting about most unfused epiphyses is you've got this really kind of smooth look to them, and they have undulations, and it's almost like a cloud or a pillow where it just looks very soft. And with juveniles, some species, you might not be able to tell what it is. I know a lot of individuals who have trouble identifying juvenile human because there's just not a lot to study. And as you can see, this does not look like a human femur, whereas this is starting to look more like a human femur. Okay, and here you can see that same thing with the epiphysis on this one, which is the end of the growing bone right here. It hasn't fused at all, and they didn't even recover it. Whereas here it's starting to fuse together, and you can see a very well-defined line. And then here is a complete adult. So now we start to get into what makes us different, what makes us unique. As you can see from this picture, a lot of mammals share similar morphological features. We have arms, we have a hand or a foot that has similar parts, same number of bones to a certain extent, depending on the species. And so everything kind of looks a little bit the same. So if you get really good with one species, you can actually identify, oh, this is a humerus or this is a femur in another species, because it kind of looks like it, but a little bit different. And the reason there's that little bit of difference is because all animals move their bodies slightly different. Their general morphology is then altered by how that species moves around through life and how they're capable of moving. And that brings us to the one key difference between humans and other animals. And I'm going to just open up the mic if anyone wants to say, what is that big difference? Anyone? Crickets? Okay. We're bipedal. Our major method of locomotion is that we walk on two legs. Most other mammals are quadrupeds. Some people might argue, oh, well, chimpanzee, they get up on two legs. Yes, they do, but their major mode of motion is not on their legs permanently, whereas ours is. So that then creates certain morphology that allows us to stand upright and makes us more sturdy on just two legs, whereas a lot of other mammals, they are on their feet, all four of them, and therefore the weight distribution and the way in which they move is completely different. So on average, if you compare two quadrupeds, like a horse and a goat, you're going to see more similar morphology than you would see if you compared the goat to the human. Okay. For us, our pelvis tends to be very broad and shallow, meaning it's not that high. Okay. So here you can see on the pelvis here, it's not super high from point A to point B, but if you would look at it from the front or the back, you would see that it's actually rather wide. Our femur is the longest bone in our body, and it has a single linea aspera, which is right here on the back of the femur. Sometimes it's kind of broad with a bit of a ridge, and this is for all of the muscle attachments because we're such great walkers. Excuse me, one second. And a lot of animals, they don't have that very well-defined ridge like that because they're distributing their weight across four legs rather than two. The tibia and the fibula, which is the two lower legs right here, the two lower bones of the leg, ours are not fused. Not all mammals, but a lot of mammals, for extra support, those two bones are fused together at either the top and or the bottom for extra support. And our tibia in cross section, which is the bigger of the lower two legs, is triangular in cross section, whereas theirs tends to be more flat or rounded. And that triangular morphology, much like, you know, a three-legged stool, it gives us added support. Okay. When it comes to our feet, we have a very long and narrow foot, and that's mainly just for weight distribution. We also have, much like our hands, we have a very large big toe, which helps with balance as well. So in those other mammals, we tend to see completely different pelvis. It's a lot longer. And remember, in this image, it might not look longer, but think about if you scale the human to the size of a dog, okay? So on average, if you're looking at the whole skeleton, the pelvis appears longer. The narrow aspect, that is very obvious. A lot of mammals will have a pelvis that is sometimes as much as half the narrowness of ours. The femurs are relatively short compared to the overall body size. And see, as you can see here in this image, it's almost half the size of the human femur. Okay. The diameter can be twice as thick as a human femur, and they may have a double plateau linea aspera, but not all species do. Sorry, I accidentally deleted a word. The tibia and the fibula are often fused, as I said before. And the tibia, which is the lower leg, the larger of the lower leg bones, is often more rounded in cross section. The legs of larger mammals have modified toe bones. So typically you'll see, rather than this kind of dog bone, sometimes you'll see just fused together metacarpals, metatarsals, things of that nature, rather than individual ones like we have. And the reason they have that is for speed and agility. The next key difference is looking at the vertebrae. So humans tend to have very large, broad, flat vertebrae body. And by flat, I mean the tops and the bottoms are flat. Okay. We have relatively short spinous process, which is the projection that you see on the back. And it's that bump that you feel on your back. And by short, I mean, even the longest ones are 2 to 3 inches at most. And most people, it's only about an inch or so. Okay. And this is where a lot of muscle attachments occur. Our sacrum, which is, as many of you know, the problem and source of much back pain, but this is also where the pelvis connects. Our sacrum is triangular, okay, composed of 5 fused vertebrae. Some individuals will have more or less, but for the most part, on average, we have 5. And it's very kind of broad compared to animals. And that goes along with the general appearance of the pelvis, how it's narrower in animals and other mammals. And our sacrums tend to be very flat, anterior to posterior, which means front to back. Okay. There is a lot of morphology differences between different parts of the vertebrae. As many of you know, we break up the spine in cervical, thoracic, and lumbar regions. The cervical is your neck. Thoracic tends to be your chest area, where you see muscle attachments for ribs. And then the lumbar is the lower back. And then you have your sacrum. Okay. Mammals will have different morphological changes as well, but ours tend to be very unique. And notice here how you can see the projections of the spinous process. They tend to be more downward, okay? Whereas with animals, they pretty much go straight back. You guys see the difference in how long these spinous processes are? It's very significant difference. Other than the spinous process, we also see changes in the bodies of the vertebrae. And I wish I would have put in a picture of snake vertebrae. They have very concave bodies, okay? And sometimes you have convex bodies as well. So they're not flat, they're either more concave or more convex, depending on the species. And some will have a more convex top or bottom, or concave top or bottom, depending on how they all articulate together. You will occasionally see some species that have flat ones, but it's not as typical as seeing more convex or concave. And here you can see what I mean by a sacrum. They tend to be very narrow in size. And they do project a little bit on the alas, but for the most part, it's very narrow because overall the pelvis is very narrow. Species also have fewer fused vertebrae on average. So this one's got 1, 2, 3, 4 fused vertebrae. Okay. And so here you can actually see these animals at the bottom are on average smaller than humans. We've got a goat and the variety of vertebrae, and also a pig over here. And you start to get an idea for what a cervical vertebrae looks like. They don't have major projections to the side with the transverse processes. So that means that one's a cervical, and that one's a cervical. So you start to be able to identify where in the body it goes. It also helps if the animal is articulated on the ground for you. The next thing we want to look at is the forelimbs. Because our bodies are designed to do different things than animals, we have different morphology of our bones. We can swing, we can throw, we can do all sorts of stuff because we have a ball and socket shoulder. Okay, here's the ball, here's the socket. Okay, mammals that are quadrupeds, they don't have this design. They would have trouble walking on all four because this doesn't support weight very well. Okay. And because of this ball and socket design and the fact that we're not bearing a lot of weight on this joint, the general morphology is going to be vastly different than mammals. We're going to have a long axis of the scapula. Okay, it's very long in this direction. Animals tend to be more long in this direction. Okay, we have a very well-defined scapular spine, which is this ridge right here. And we tend to have a very triangular shaped scapula. Okay. We also have a clavicle. It's somewhat unique in mammal morphology. There's a couple of species that have them, but they look completely different, and I'll cover what one of them is. When it comes to our forelimbs, once again, there's completely different morphology because we are not bearing weight. They're not as robust. If you look at the leg bone of any small mammal, they tend to be thicker and they tend to be more solid, whereas our arm bones tend to be kind of more gracile. They're long because they can be long, and they can be very delicate because we're not bearing weight on them. Okay. Once again, our forearms with the ulna right here and the radius are not fused, whereas in animals, they sometimes are. Much like our big toe, we have a relatively large thumb, which is right here on the human. And even in our nearest cousin primate, they have a thumb, but as you can see, it's very kind of small by comparison to ours. We have a very well-defined, because of our manual dexterity, a very well-defined thumb. So looking at the forelimbs of mammals, they are designed for a more front to back stride. They're not, throwing balls or jumping up and down too often. It's a very front, back, front, back, front, back. So they tend to have more gliding joints rather than ball and socket. Okay. Because of all of this, their scapulae look completely different. While you could say this is triangular, but ours is triangular in a different direction. Ours would come down to a point down here, whereas theirs goes more towards the body with their triangle. Okay. Some people like to say it's more of a parallel rectangle almost. Okay. And their long axis is parallel with the scapular spine, whereas ours goes in the other direction. So here's their spine. And as you can see, their spine, because they're not doing as many complex movements with their ball and socket, because they don't have one, their spine isn't as well developed as ours on ratio. Clavicles are almost absent in non-human mammals. The birds actually have what's referred to as a coracoid, or the wishbone, which in this image is right here. But morphological it's completely different, and it doesn't serve the same function as the clavicle in the humans. Forelimbs in animals, the humerus, the radius, the ulna are all weight bearing. So they tend to be very robust. And you can see very well-defined lines where muscle attachments occur. Unlike the humerus that you saw on the slide previous, yeah, you can see where muscle attachments occur, but they're not as well-defined as this. And that's because of the amount of weight that they're putting on these legs, and then how much movement they have to do while they're bearing all this weight. Here you can see a good example of a fused ulna and radius. It's fused both here and here, okay? They typically have very small thumbs, or they're more proportional with the other fingers, as you can see in this raccoon here, okay? And that tends to help you as far as identifying the difference between bear and human. And a lot of people tend to mix up bear paws with human hands because they're about the same size, and a lot of the bones are roughly the same length. But if you look at the thumb, there's a size difference. It doesn't stick out like a sore thumb, so to speak. And also the morphology at the tops and bottoms of the metacarpals and the phalanges are completely different between the two. Now to get at more the insides of the bones. The morphological differences extend onto the interior of the bones because these bones are made for different things. Trabecular bone, or spongy bone, is more dominant in humans. So here you can see two human bones and the midsection of them, whereas these are animals. Okay, they're very hollow. They don't have as much sponginess. And the reason why we have this sponginess is, think of a bridge. Bridges have a lot of interconnecting parts, especially like suspension bridges. You have to have all of that interconnectedness to help give it support. It's the same with spongy bone. All of this helps make the exterior part of the bone stronger. It allows us to be able to jump and disperse the energy and impact in a very even way. Most animals aren't jumping. Most animals also have a thicker cortical section. They don't need all of this sponge support on the interior. Towards the proximal and distal ends of the bone, the two ends basically, you'll see completely different changes in this cortical bone. This is an animal. This is a human. You see how the sponginess or the fibers tend to be more compact and dense. Animals do have spongy bone, as you can see here, but it tends to only be at the tops and the bottoms. See, as you can see right here, they have a little bit of spongy bone right there. They don't have it all throughout. So when you find a fragment of bone, this is one key way that you can really tell the difference between animal and human. Next is looking at what I was talking about earlier, the cortical bone, that exterior part of the bone. And you can only really see this once again in cross section, like you see here. That's the cortical bone right there, that thick outer layer. It is much thicker in animals. And that's because they don't have that awesome spongy cortical bone, the spongy trabecular bone on the inside. This is more noticeable in the humeral and femur areas, where the cortical thickness in animals is like 4 times what it is in humans. So there's a little diagram to kind of demonstrate it. Okay, so animals will have a very, very thick cortical bone by comparison. The cranial bone also shows some of these main differences. You get more of that cortical layer and more sponginess in a human rather than with an animal. You also want to look at the morphology on the inside, okay? Here you can see where a lot of the blood vessels are right up against the cranial bone. And in animals, you get this funky, like, undulating waviness. You don't get these very defined, this is where the blood vessels are. Occasionally you'll get it in animals, but you also will get this. Humans do not have this super weird bumpiness, except for sometimes in parts of the occipital. For the most part, the interior of our cranium is very smooth with these almost like rivers running through it. Teeth are also a really good indicator. Most of you have looked inside your mouth, someone else's mouth, or something. You know what human teeth look like, okay? We are omnivores. We have a variety of teeth for eating a variety of things. And you can tell also by looking at other mandibles that they eat other things. Here you can see a pig, and they tend to have more bumpy, rigorous kind of things because they're tearing up a lot of small, meaty little animals and things of that nature. And here is the whole conundrum. Is it human or is it bear? And you can see what I was talking about earlier, where morphologically, these things are roughly the same size. But if you look closer, that's the thumb. It almost looks the same as the rest of the fingers. So if you have a bear paw without the thumb, bring in an expert, because then you got to look at all of these little tiny morphological differences that you don't see so much over here, okay? It's something that someone who's well-trained would be able to quickly identify in an instant. And you can see that a lot of these bones are roughly the same size and shape, but that thumb is one of our key differences, along with the way that the distal and proximal ends of the phalanges are shaped. So just to kind of run through some general, like what you may find. I highly doubt you guys are going to find this. I hope you don't. That's actually excavated. But what we look for as bioarchaeologists when we're trying to determine what it is look at the positioning of the body. Does it look deliberate, like it's a burial, or did it just die somewhere and that's its natural kind of posture? These are things we look for. We also, once again, want to just kind of get a general look for the morphology. I can tell right away as a human and its curvature, that's not normal for humans. And if I were to look at this a lot closer, I'd be able to tell there's no pathology, therefore it's not human. And I would like to emphasize even experts have trouble identifying stuff. And there's been numerous times where I've had to consult with colleagues, and we kind of bounce stuff off each other's ideas, and we try to challenge each other occasionally. And this would be a good instance of that. Sometimes when something is so fragmentary and even burned, it's a little hard to identify. And it's okay if you don't know what it is. Even among the field of experts, we sometimes get puzzled by things occasionally. So, what if it is human? Okay. Let's go over two different scenarios. I think it might be human. Now what do I do? So the most important thing I can stress to you, do not touch it, do not move it, do not pluck it out of a half-buried context. Just leave it be. Do not attempt to rebury it, bless it, or excavate it. Take a picture, and you need to send it to SiteWatch, your agency, archaeologist, through your coordinator for identification. And I cannot stress this enough. I've had numerous friends send me pictures of bones they find, and some of them have been human, some of them have not. What helps us out is if we know how big it is. So use a scale. It doesn't have to be like a cute little black and white ruler that are like really cheap. You could throw in a pencil. You could throw in a quarter. You can put your hand next to it for scale. Something that helps us get an idea for how big it is. Okay. If an expert thinks there's a chance that the bone is human, they will work with the agency archaeologist. The archaeologist can then notify local law enforcement if they believe there is a burial. So it is human, and you're 100% sure. And yes, even untrained professionals can be like, oh yeah, that's a human. And I would trust your judgment if you're like, yeah, that's a human. Once again, do not touch it, do not move it, do not pluck it out of a half-buried context, do not rebury it, do not bless it, do not excavate it. Your job is just to notify people. So if you find it and it's clearly and unmistakably human, and you can positively identify it without touching it, and that's the key, do not move it around, don't touch it. immediately call your coordinator. Your coordinator will notify the LE and the agency archaeologist. If you cannot reach your coordinator, inform dispatch and the agency archaeologist directly by calling, identifying yourself as a site watch, and informing them that the element is on an archaeological site. Consultation and tribal notification will have to occur. There's different ways in which this occurs in the world, depending on if it's found on federal land or state land. I don't know how much of the nitty gritty you all want me to go into on that. But are there any questions, comments, concerns? Anyone? Jessica, you still there?
I am. I don't see any questions coming up on the email list at all. I think you've wowed us.
It's a lot to cover, and I really stress the whole, like, even after a presentation like this, like, even if you can't identify the difference between animal and human, it's okay. You know, just being able to tell if it's bone helps a lot. And it's better to report it as possible and having it ruled out than to be like, I'm just not going to bug someone. No, we like to be challenged, archaeologists, as far as like, what is that in the picture? It's always fun to receive those pictures. Okay.
Yeah. And it is true that your agency archaeologist is always going to want to know if you have something that, even if it's iffy coming out of a site that's eroding, because you're not going to be the only person that's wondering if there is a human bone there. I'll also interject. I have worked as an archaeologist since 1994. And I've been on numerous excavations that had plenty of bone on it, both human and animal. And I can tell you that with elements that are not articulated, I am still often unsure of what I'm seeing. And I still often, when I was in the field, would ask our animal bone experts to take a look at stuff. So being unsure is pretty much universal. Well, maybe not universal, but it's very, very common.
No, it's universal, especially when it's like half buried. I'll admit there are times when I see only a little bit poking out and I'm like, that could be this or that. And until I see a bigger picture, I'm still like humming and hawing a little bit.
Right. And so that's the reason that not only for, cultural sensitivity reasons, but for primarily culturally sensitivity reasons, you don't want to be plucking things out. You can damage them, you can desecrate them, and you don't want to be in that situation. But also, you're not guaranteed of being able to make an identification anyway. So we have some questions. The first one is, could you show the slide with the osteology guides one more time?
Yes, I can. Let me figure out how to share my screen again. Oops, what did I do? Great. Hold on. Okay, can you guys see that? Am I sharing okay?
I do not see it. It says end of slideshow, click to exit.
Weird, because it's showing on my end. Let me try changing it again.
Okay, well, while you're doing that, I have another question. And I think this is probably best addressed to Michelle Ency. What is the typical tribal response to a report of human, it just jumped around on me. Okay, so Michelle says, tribes always want bones left on site and reburied in a place or as close as possible to the original location. That does not mean that you should be doing that. There's a government to government consultation that goes on. Tribes are sovereign nations. And so there needs to be an official process of communication. Okay, so these are the osteology.
I'm a big fan of Tim White's work. He's a fellow UC Riverside alum where I did my undergrad. He got his Ph.D. So these two are both by Tim White. The person he has photographing bone, it's phenomenal. And what I like about both of these texts is it actually goes into some of the structural aspects and some of the different morphology and what to look for. Things like this tend to be cheaper. And this is one of the better atlas guides. And if you want something cheaper, put in like atlas guide and human skeleton or human osteology. These tend to be more picture focused, just pictures. But as I said, just making yourself familiar with what the bone looks like, that's the first hurdle of being able to identify human remains. It's just getting used to them. If you wanted to go all out, what I highly recommend to people who are going into human osteology is getting yourself a plastic skeleton. Actually having the 3D representation of it, even if it's slightly scaled down, it really helps. It does more than just having a picture to look at. It gives you something you can touch and feel. And a lot of human osteologists that I know were very tactile learners. So having that 3-dimensional thing is great. However, most decent plastic skeletons are going to cost you about $100 or more, whereas a lot of these you can find 20 to 30 bucks.
Okay. And then, so for anybody who doesn't have the chat open, we have a question: can we have online access to the presentation for future reference? And the answer is answered by Michelle. We're recording the presentations to make them available later, but we can also ask, you can also just ask for the PowerPoint presentation to post on our website. There was somebody else who asked, I think it was Mark Henderson, that asked if we could publish this as a field guide. And I guess my answer probably short term would be, if we're going to publish this as a PowerPoint presentation, there's a way in the PowerPoint that you can go and print the presentation off of your home computer. You can print the slides.
Yeah, we cannot quote unquote publish this because of the copyright infringements. I don't have permission to use a lot of these photos, but it's for educational purposes. That's the reason it can be used for a PowerPoint. So yeah, you guys can't mass produce this, but you can print for your own self. Yeah. And I'll
print it off of your computer.
Yeah. And I'll send you a copy of this.
Okay. So thanks so much for the presentation. Very helpful. So yeah, thank you, Kieffer. I appreciate you coming to speak to everybody today.
No problem. I might not be super active in the archaeology world, but I love the fact that SiteWatch is there and that you guys are protecting a lot of the cultural resources in this state. I look forward to retirement one day and joining your group.
Don't we all? Awesome. Well, you're getting a lot of thanks on the chat. And
if you guys want me to come back and go into some more nitty-gritty related stuff, I'm more than happy to do so. Teaching is a love of mine, and I am adjunct at Santa Fe Community College for just that reason.
Okay, so can our chapter coordinators get in touch with you on an individual basis for that sort of thing?
Yeah, they can contact me via my Gmail, which is clkieffer, KIEFFER @gmail.com.
Okay, great. Thank you so much. I appreciate it.
No problem. You guys have a great day. Okay.
Awesome. You too. Okay. All right, so it's 11:59 and we are going to have an uninterrupted lunch until 12:30, at which point Marilyn Markle will come on and give us a chapter update at Mimbres. I would suggest that anybody who would like to chat, go ahead and turn their mics on and their screens or their videos on, and we'll just sort of leave it open for anybody who would like to talk over Zoom. I know there's some debate as to whether soup on Zoom is a good idea,